Have you ever wondered what it takes to protect some of the most beautiful, most elusive creatures on our planet? Well, birds of paradise, they're famous for their absolutely stunning feathers, but telling one species from another in the wild, that can be a massive challenge, even for seasoned conservationists. So what if you could give them a new superpower, an AI that could identify these birds instantly and with incredible accuracy? Well, that's exactly what a team of researchers set out to build, and the story of how they did it is pretty amazing.
All right, so let's meet the stars of our show. The goal was to teach a computer to tell apart 5 specific species from just a single photograph. We're talking about the lesser bird of paradise, the red bird of paradise, the crow-like, the homahera, and the Arfac parodia. Now, each one of these birds presents its own unique puzzle, something biologists in the field know all too well. So where do you even begin when you're trying to teach an AI about something as complex as a bird? Well, the researchers started with a baseline model. This was their first shot, their first attempt to see if they could crack this identification problem. Now, they didn't just start from scratch. They used a really well-known and powerful blueprint for this kind of work, a type of AI called a convolutional neural network, or CNN. Specifically, they used an architecture called VGG19, which is famous for being really good at spotting complex patterns of images. It was the perfect place to start for our feathered friends. And how did that first attempt go? Well, it scored an accuracy of 85%. That's actually not bad at all. That's a solid B on its first test. It means out of 100 birds, it got 85 of them right. But for critical conservation work where every single data point can make a difference, there was definitely room to do better. But see, that 85% number doesn't tell the whole story. Not even close. You have to dig into the details. Look at the Cendrawasih parodia Arfac. The recall score is only 76%. For a biologist, that's a huge problem. It means the model completely failed to identify nearly a quarter of that species it saw. When you're trying to get an accurate population count, that is a massive blind spot. The researchers knew they could push that number way higher. So they went back to the drawing board and added 2 really clever techniques designed to basically supercharge the AI's learning process. They were going to give it a much better education on bird identification. First up was something called data augmentation, and this is a fantastic trick. You take the pictures you already have, and you digitally flip them, rotate them, zoom in on them. It's like showing the AI the exact same bird, but from dozens of different angles and in different lighting. This is so important because in the wild, let's be real, birds are never sitting in the perfect pose for a photo. The second secret ingredient was batch normalization. The easiest way to think about this is like a stabilizer for the AI while it's training. It keeps the whole learning process steady and efficient, and it stops the model from getting confused or stuck on the wrong path. It just helps it learn way, way more effectively. So they put in all this extra work. They added these 2 big upgrades. Did it actually make a difference? Oh yeah. It made a huge difference. The new and improved model wasn't just a little bit better, it was a total game changer. Check this out. The final accuracy score rocketed from 85% all the way up to a staggering 97%. Now that is a massive leap in performance, and that's the kind of number that makes a tool like this incredibly reliable for actual fieldwork. I mean, just look at that difference side by side. That 12-point jump from the baseline model to the final one, that's the difference between a promising experiment and a genuinely powerful tool that conservationists can trust. And here's where it gets really exciting. Let's look at how this impacted specific species. Remember the Cendrawasih parodia Arfac, the one the first model kept missing? Well, its recall jumped from 76% to a perfect 100%. That means it went from missing almost a quarter of them to correctly identifying every single one. And for the Cendrawasih kuning kecil, its precision hit 100%. That means it completely stopped making false alarms. It no longer misidentifies other birds as that species, which is absolutely critical for getting clean data. And here is the final report card. I mean, just look at those numbers. Precision and recall scores are fantastic across the board. For the Cendrawasih mira, the red bird of paradise, it's a perfect 100% on both. That means it finds every single one and it's never wrong when it thinks it's found one. This is the level of reliability that can truly, truly transform the work being done in the field. Okay, so an AI got really, really good at a birdwatching game. So what? Why does this matter so much? Well, because these numbers, they translate into a powerful new reality for the people on the ground working to protect these incredible animals.
You don't just have to take my word for it. The researchers themselves put it perfectly. This work makes a direct and, quote, important contribution to conservation efforts. This isn't just some academic exercise. It's about building a real system that can be used in the real world to make a real difference.
So what does this actually look like for a biologist out in the jungle? It means faster, way more accurate population counts from things like camera traps or even drones. It drastically cuts down on the thousands of hours of painstaking manual photo identification. This lets them monitor much larger areas for much longer periods of time. And that is how we get a better, clearer, bigger picture of the health of these vital bird populations.
So this all leaves us with a really exciting thought. This automated system is a huge leap forward for monitoring the birds of paradise for sure, but it also serves as a blueprint for so much more. With technology this accurate and this accessible, what other species could we help protect? What new frontiers can we now explore in the absolutely vital mission to preserve our planet's incredible biodiversity?